Hello everyone! So now we are going to continue our lesson in geometric optics. So in our previous video, we studied how light rays reflects in mirrors. Now this time we're going to study how light rays pass through the lenses. Okay? So we're going to deal with the refraction of light. And since we're going to deal with the refraction of light, let us review first what is this refraction. Okay? So refraction is the bending of light. So whenever that the light enters a different medium, it bends. Okay, naga-bend siya. As you can see here on the screen. So we have here the light ray which is from the air, enters the glass, and then balik siya sa air. Okay? Okay, there. So, in this video, same na ang aton nga study. But we're going to use concave and convex lenses. So, lantawon ta kung how light rays pass through those lenses. Okay, so here it is. Now, in the telescope, they are using convex and concave lens. Okay. So, hindi lang siya nga kay concave lang or convex lang ang ginagamit. It's the both of them. Okay, so kung lang tawon tadi, we have here the parallel light rays. Okay, so for the parallel light rays, okay, there, nag-enter siya sa convex lens. Okay, so as it enters the convex lens, if you're going to take a look here, na ang aton nga light rays, nagaamat-amat, gamay ang ilang distance between. Okay, and then before pa siya mag-converge. Before pa siya mag-converge, we have here the concave lens which allows the light rays to be parallel again. So, anong ginhimo niya? Ginpa-parallel niya ang manug-converge nga light rays. So, amo na siya ang purpose man sang aton nga convex and concave lens as we use telescope. Okay? So, there. So, because of that, we were able to see Saturn or Venus, kung ano mo makita mo sa kalawakan, tungod sa amo nga lenses. Okay? So, there. So, always remember that light rays are always refracted towards the thickest part of the lens. Now, for the convex lens, it is thicker at the center, while for the concave lens, it is thicker on its edge. Okay. So let us have here the concave lenses. So concave lenses allows the light to diverge or to spread out. Okay, so in these lenses, so damol siya sa may kilid. Now, amo na siyang itsura kung paano siya mag-spread. But then, ano ginasyaayhan or paano ginaayhan nag-amo ng iyang itsura. Okay, so let us have here our lens. So we have here the parallel light rays and then the refracted rays. So we have here the light rays. These are the incident rays. These parallel light rays are the incident rays. So as they enter the lens, they spread out. Now the pass-through lens light rays are called as the refracted rays. Again, they are called as the refracted rays. Now, always remember that these refracted rays are always aligned to the focus or the focal point. So, paano na siya? We have here the sight lines. So, if we're going to extend the sight lines, kung lantabon nyo, they are all focused on the focal point. Okay, so wala na siya yung pinagusto lang nga spread siya. Kundi, may basihan gina siya permi, may focus na siya permi. Okay. Now, let us have here an example. So, we have here the concave lens and we have here the object and of course, the observer. So, hindi ka kalantaw sang bagay kung nagdamay o nagdako sa isa ka lens kung wala observer. Ginihan. Okay. Now, for example, kay since malens kita, nagkuha ko sang props. Props. Always remember that in lenses, the observer, which is you and me, are always in the opposite direction of the object. Kinihan? So, hindi pwede nga malantaw ka using lens and then nag-aamo ka na. O paano man makitaan kung nag-magnify or nag-reduce kung amo na siyang imo pag-plastar. It should be the lens must be at the center of the object and the observer. Kindis? Kaintindi? 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 Okay. Another. Always remember na kung diin si observer, ara na dira permi ang real part. So, you are real and I am real. Insyinihan? Sige, again. If this is the lens, I am the observer and this is the object. Okay. Kung diin ka gani or diin ko, ikaw na permi or ako na permi ang real part. I am the observer and then I am real. Ano na siya? Another. Kung diin ang object, amo na permi ang sa virtual na part. Now, if you're going to compare bala class in mirrors, di ba sa mirrors, kung diin gani si object, dira na ang real part. Now, in the case of lenses, siya lain naman. Kung diin si object, siya si virtual. Kung diin ka, diin ko, ikaw na ang real. Pabinsara lang ikaw ang tutuod. Next class. Okay. Sige. So, let us take a look how light rays pass through the lenses, specifically in the concave lens. So, we have here the light rays. So, in the first light ray, we have here the incident ray which is parallel to the optical axis, and then nagtiko siya outward. Why? Kay ga-spread out siya gani. Spread out siya. Okay? Sige. Now, this refracted ray is aligned to the is aligned to the focus or the focal point. Gets lang siya. Kabay pa na gets lang siya. So, we have here the sight lines. And then, for the next ray, please take a look here. Then siya gyapon sa sapunga. So, here it is. If sa mirror may pattern kita nga tiko, straight tiko, straight this time, ang ato nang gidya nga pattern sa lens, haposan niya kay lens. Straight tiko, straight tiko, straight tiko, slant dali. Straight tiko, slant. Straight tiko, slant. Amo na siya ha, amo na siyang tandaan. Okay. Sige. Now, sa pag-slant ng isa ka light ray, we're going to take a look here, managtabuay nga duwa ka linya. So, these light rays, kung diin nagtabuay ang duwa ka linya, of course, dira man ma-exist ang aton nga image. Gets? Catch. Okay. So, please take a look here. We have here the object, which is nearer to the lens. So, therefore, the DO is shorter compared to the focal length. And with that, ang image nga na-form niya is, you can see here, it's located above the optical axis. Therefore, it is upright or erect. Then, this is smaller compared to the object, meaning this is reduced. And it is located on the object side, therefore, it is virtual. So, mo na siya. Nagets lang siya. So, the image formed in this lens is upright, reduced, and virtual image. Okay. Another. Always remember that if you're going to use lenses, may duwa kita ka focal point. Kung ano kalabaon sa focal length diri, that is equal to kung ano man kalabaon on the other side. But in our ray diagram, diin kita mabase. Basta gani, it should be duwa na sila class. Duwa na sila dapat. But then, on our ray diagram, diin kita ma-focus. Diin kita ma-focus, focus. Dili kita ma-focus ka sa focal point na upod ni object if concave. Again, ma-focus ka. Focus ka ha. Ma-focus ka sa focal point nga upod ni object concave lens. If you are using two light rays. Again, if you are using two light rays. Focus ka sa focal point nga upod ni object. Chindes? Okay, because there are some resources wherein they use 3 light rays. May gagamit kini kas tatlo. Siya ha. Sige, gagamit na siya tatlo. May ara gid gagamit duha ka focal point. Now, in our case here, para hapo sa inyo makit-an, so duwa lang ka light rays gamiton ta, and then igamiton ta nga focal point is ang upod ni object. Kay concave lens na siya. Concave lens, kinawaka ko diha. Ano siya. Okay. So again, DO is shorter compared to the F, or focal length. And that's for our image. Now let us have here an example. So, in your papers, in your notebooks, in your iPads, I want you all to try to plot this diagram. Okay, please have a pause. And here it is. This is for our image. Kindly check if you got it right. Now, in this case, we have here a shorter focal length compared to the D sub O, or the object's distance. Okay, now, what happened to the image? So, for our pattern, it's straight, tiko, and then slant. Straight, tiko, and then slant. So, kada tiko niya gani class, always remember that it is always aligned to the focal point. Regardless, man na siya class kung di na siya mapisto sa likod ni object, ang sa tubangan ni object. Basta kada tiko, matupong gina siya permeya kay focal point. Forever and ever. O, sige. Okay ra. So, there it is. This is for our image. We have a bright, reduced, and virtual image. So, always remember lang, class, I have a tip. In a concave lens, we are always forming a bright, reduced, and virtual image. So, that's for the concave lens. Now, let us have here the convex lens. So, convex lenses are thicker at the center. So, balik kita sa my akong props. So, I am using here convex lens. Grabe libat man si miss. Pero siya. Mga epic ko na nga faces. Ha? Mga ilong-ilong ko da. Gadaramol, magnify there. So, we're using here convex lens. Okay. So, in convex lenses, always remember that the light rays are converged or come together. They are converging. Converging, gatipon sila. Okay. So, let us take a look how light rays enters the convex lens. So, there it is. So, we have here the incident rays, which are parallel to each other. And then, we have here the refracted rays here. Refracted rays. So, these refracted rays, as they enter convex lens, so since ara sa tunga ang thicker, so therefore, nagatipon ang light rays. And with that, converging of light rays, so nagatipon sila sa focal point. Sa focal point sila gatipon. Okay. So, na siya. So, let us have here an example. So, on this example, we have here the object and we have here the focal point. Okay, so kung kay concave lens kagina, nag-use kita sa focal point which is on the side of the object. Now, this time for the convex lens, ang focal point nga gamiton naton, kay di ba hambal ni Miss, may duwa na siya dapat ka focal point. Kaysa ibang lakas nga resources, may amo gini siya, amo gini iya nga itsura. But in our case here, may use kita 1 kay 2 light rays ng gamiton. Okay. Now, so in this case, ang gamiton ta nga focal point is upod ni observer. So again, kay concave lens, ang focal point nga gamiton upod ni object. Okay? So for convex lens, ang gamiton nga focal point is upod mo. Upod mo, upod ko. Upod naton kay kita ang observer. Naintindihan? Sige. Okay. Now, let us have here our light rays. For the pattern, it's the same. Okay? So, ang pattern naton is straight tiko and then slant. Straight tiko and slant. Okay? So, we have here straight and then tiko. Pag tiko, line, linya, kay focal point, tupong, kay focal point. And then, for the second light ray, slant. Slant, slant, slant. Forever and ever. Okay. Now, if you can see here, in the screen, wala sa may nagtabuay nga duwa ka light rays. So, what are we going to do? We're going to extend the refracted rays. Again, we are going to extend the refracted rays. So, if sa mirrors, ang may karapatan mag-extend are reflected rays, for the lenses, ang may karapatan mag-extend are the refracted rays. Okay, so let us have here the extension. So we have here the sight lines. So, if you're going to take a look here on the screen, ang sight lines nagtabuay. So, kay dira sila nagtabuay, meaning, ara manda ang image naton. And for the image, it is located above the optical axis. Therefore, it is upright or erect. It is located on the object side. Therefore, it is virtual and it is larger compared to the image. Therefore, it is enlarged. So, amo na siya mag-determine sang image. And take note that we have here longer focal length compared to the DO. Okay? Now, let us have here our example. So, I like you to have your notebooks, have your ball pens, have your pads there, or you can use your iPads to make the array diagram. Now, in this case, we have a shorter focal length compared to the object's distance. Now, what are we going to do with this? Ano na siya? Okay, so let me take a look let's see if you got it right. So here it is. So for our image, we have the same pattern. It's straight, tiko, and then slant. Now, in this example, we have here the light rays nga nagtabuay sila sa observer side. Okay, so we have here an inverted, and if you're going to take a look here, pari-parihas ng iya nga kadakoon. So therefore, the image is the same height with the object or same size with the object, and then this is real because it is located on the observer's side. So amo na siya. Okay, so again, in this case, we have here the focal length which is shorter compared to the DO, and this is for the convex lens. Okay, is it clear? I hope naintindihan lang siya. Okay, so this is it for our ray diagram. And to take note lang, any lens that is thicker in the center than in the end is convex, and any lens thicker at the end than in the center is a concave lens. So if you're going to use convex lens, so amo ni siya ang aton nga itsura. Just like this, I am using here convex lens. Okay? And then for the concave lens, so it appears smaller. Okay, so that's it. And this is all for our light rays in using the lenses. So I hope that you've learn something and I hope that you understand lang kung ano ang gina-explain ni Miss. So, hopefully that I help you in understanding geometric optics, most especially in dealing with light rays as it enters the lenses. So thank you so much for watching and have a great day. God bless you all. Bye-bye.